Hello, and welcome to Our Earth, its climate, history, and processes. I'm David Schultz. In this lecture, we want to talk about the interior of the Earth. Why is it composed of these different layers, and what differences in composition and characteristics do these different layers have? During the formation of the solar system, when the Earth was still molten, the Earth underwent a process called differentiation. This is where the heavier elements sank to the center of the Earth. We know that iron melts at a lower temperature than silicate minerals. Silicate minerals are simply those minerals that are composed mostly of silicon and oxygen. At the time of this differentiation, both iron and most of the silicates were melted on the Earth. So this allowed the heavier iron to sink to the bottom and the lighter silicates to rise to the top. The sinking of the iron led to the release of gravitational energy, which produced heat in the interior of the Earth, and of course the decay of radioactive elements that were trapped inside the Earth also led to internal heating of the Earth, internal heating that goes on to this day. So this was what happened, say, during the first 100 million years or so of Earth's evolution until we ended up with this layered Earth. The layered Earth that we're talking about has four layers. It has the Earth's crust near the surface, the mantle, the liquid outer core, and the solid inner core. The crust is composed primarily of oxygen and silicon. It also has aluminum, iron, magnesium, and many other elements. The mantle has about the same concentration of oxygen, but much higher magnesium concentration, a little bit lower silicon concentration. As you go to the outer core, the composition changes dramatically. This outer core is now 85% iron and 5% nickel, 5% oxygen, and 5% sulfur. As you go into the innermost core, it's 94% iron and 6% nickel. So you can see the increase in iron concentration, nickel, as you get towards the center of the Earth, and also the reduction in the amount of silicon and oxygen as you go into the center of the Earth. So let's talk about each of these different layers. The Earth's crust is composed of different plates, and there are two types of crust. There's the oceanic crust, which is primarily basalt, and you have the continental crust, which tends to be more granitic. Currently, the crust is composed of these different plates, and these plates move around on the Earth due to the plate tectonics. So we'll talk more about that in later lectures. The mantle comprises 80% of the volume of the Earth. It's mostly rock called peridotite, which is mostly olivine and pyroxene. And if we're lucky, we can see some pieces of the mantle that occasionally are brought to the surface of the Earth in what we call ophiolite sequences. These are sections of ocean crust and upper mantle that have been uplifted during plate tectonic processes and exposed on the surface of the Earth. As we go down towards the outer core comprises 1/6 of the volume of the Earth, but 1/3 of its mass. This is because of the much higher concentrations of iron. As you get to the center of the Earth, the temperature is increasing, but of course so is the pressure, and there is this zone where, despite the increasing pressure and the greater tendency to keep things solid, the temperature is so high that the iron melts. And that's exactly what happens here in the outer part of the core. As you go to the inner core, despite the higher temperatures, the pressure is so high that the iron returns to a solid form. So those are the four layers of the Earth. Because we live on the surface, we have a lot of experience with the crust, both the continental crust and the ocean crust. We have less direct experience with mantle. As I mentioned, the only direct observations we have of the mantle are the pieces of peridotite that we can find in ophiolite sequences. We have no direct experience with what the inner and outer core look like. So, to summarize today's lecture, we saw that there were four layers of the Earth: the crust, the mantle, the outer and inner core. The crust has the highest percentage of silicon, and the inner core has the highest percentage of iron. Mantle occupies the largest volume of the Earth, but it's mostly composed of a rock called peridotite. Ophiolites are cross-sections of the upper mantle and the crust, and these are key elements in telling us what the structure of the upper part of the Earth looks like. And then finally, the outer core is liquid, but the inner core is solid, and both have a very high percentage of iron.